Hello everyone, in this video we're going to explore the topic 5.3 determining intervals on which a function is increasing or decreasing. Alright, now first we're going to talk about the increasing and decreasing function. Definition of increasing and decreasing function. A function f is increasing on an interval if for any two numbers s1, s2 on the interval such that s1 less than s2. This implies that f of s1 less than f of s2. Right? So you look at the right hand side right here, you see that the function is increasing on this interval right here. Right? Because you're gonna take s1 here, right? And then s2 here. And observe that s1 less than s2. Then you see that f of s1 less than f of s2, right? A function f is decreasing on an interval if for any two numbers s1 and s2 on the interval such that s1 less than s2 implies that f of s1 greater than f of s2, and you see that the direction of this guy and this guy opposite, right? This guy and this guy have the same direction, so it's gonna be increasing. If they have opposite direction, it's gonna be decreasing, right? So we look at the right hand side. Now suppose I have s1 right here, right? s2 right here, and you see that s1 less than s2, right? But f of s2 less than f of s1. You see that, right? So you need to be careful, right? Now we're gonna talk about the theorem, the test for increasing and decreasing function. Let f be a function that is continuous on the closed interval a and b, and differentiable on the open interval a and b. If f prime of s greater than 0 for all s in the open interval, then f is increasing on the closed interval a and b, right? Greater than 0 is going to be increasing. We talk about the f prime, okay? Keep that in mind. This guy different from this guy. This guy is the definition. We just talk about the function f of s. The theorem, we talk about the function f prime of s, so you need to be careful. Number 2, if f prime of s less than 0 for all s in the interval a and b, then f is decreasing on this interval, right? So this less than is going to be decreasing. Alright, so we look at the picture right here. This one is the function f of s, right? Now the interval from here to here, right? The function is decreasing. You see that? So within this interval, f prime of s less than 0. You see that? F prime of s less than 0, the function is decreasing, right? Now within this interval all the way to infinity, you see that? The function f of s is increasing, right? So f prime of s must be greater than 0. Why? You know that f prime of s is the slope of the tangent line, right? So you just draw the tangent line right here. It doesn't matter what tangent line you're going to draw, you always get the positive slope, right? Similarly, on the left hand side, it doesn't matter where you draw the tangent line, you still always get the negative slope, right? That's why f prime of s less than 0. Don't forget to use the Christmas tree trick, right? If the tangent lines go in this way, slope is positive, right? If the slope is positive, the function is increasing, right? If the tangent lines go in this way, the slope is negative. If the slope is negative, the function is decreasing, right? If the tangent lines go in this way, which means the slope is 0. If the slope is 0, the function is constant, right? And if the tangent lines go in this way, the slope is undefined, right? Now you look at this interval right here within a and b, it's going to be constant. constant, which means the slope is 0. You see that? Alright, so keep that in mind. So you work on the increasing or decreasing function problem. You need to be careful with the graph of the function right here. The given graph f of s will be different from the given graph f prime of s. Alright, so you need to be careful. Now let's take a look at the first example. Given the function f prime of s, you see that? Alright, this guy different from this guy. This one given f of s. Alright, now intervals on which f is increasing or decreasing. The graph shown to the right is f prime of s. The derivative of f of s. Using the graph, find the critical values for f of s and study the intervals over which f of s is increasing, decreasing, and justify your answer. Alright, now we look at the right hand side right here. This is the graph of the function f prime of s. So in order to know if the function is increasing or decreasing, we need to check the sign of f prime of s, right? If it's greater than 0, less than 0, or equal 0, right? So we need to find the 0 of the function f prime of s first, right? We have 3 zeros. The first one is right here, the second one is right here, and the third one right here, right? And you know that the function f prime of s is defined on the entire intervals, right? So we have the 0 f prime of s equals 0 when s equals 0, 2, and 4, right? Now we need to find the interval where the function is increasing or decreasing, right? So we look at the theorem right here. The function f is increasing on the interval a and b if f prime of s greater than 0, right? It's gonna be above the x-axis. Alright, so you need to look for the interval that's above the x-axis, right? It's gonna be this guy right here, right? And this guy right here above the x-axis, right? So the function f of s is increasing on the interval 0 to 2 and 4 to infinity, right? And the function f of s is decreasing on the interval negative infinity to 0 and 2 to 4, right? Because on this interval the function f prime of s is below the x-axis, right? Example number 2. Intervals on which f is increasing or decreasing. We need to use the first derivative, right? Find the intervals on which f of s is s cubed minus 3.5, s squared is increasing or decreasing, right? So we need to take the first derivative. It's gonna be 3s squared minus 3s, right? And then you let the first derivative equals 0, right? So you have f prime of s equals 0. It's the same thing as 3s squared minus 3s equals 0, right? I'm gonna factor 3s out, so it could be 3s times s minus 1 equals 0, right? This one is the 0 product, right? So s equals 0 and s equals 1, right? Now I need to use the sign chart to check for the sign of f prime of s, right? Now in order to check for the sign of f prime of s, I need to test the number, right? So I pick a number 2 right here within the interval 1 to infinity, right? I substitute this guy back over here. I need to test to see if it's positive or negative, right? So I have 3 times 2 squared minus 3 times 2. It's gonna be always positive, right? So this guy is positive, and you keep changing the sign, negative and positive, right? This way only correct if you have the 0 with odd multiplicity, right? If you have 0 with even multiplicity, it's gonna be totally different, so be careful. Within this interval, the function is increasing because f prime of s is greater than 0, right? The function is increasing. This one, the function is increasing because f prime of s greater than 0, right? Within this interval, the function is decreasing because f prime of s less than 0, right? Alright. Here is the guidelines for finding intervals on which a function is increasing or decreasing. Let f be continuous on the interval a, b. To find the intervals on which f is increasing or decreasing, use the following step. First, locate the critical numbers, which is this one right here. Right? Of f in the interval a and b, and use these numbers to determine your test intervals. Now, number 2, determine the sign of f prime of s by picking a test value in each of the intervals. Step number 3, use the theorem for increasing and decreasing function to determine whether the function increasing or decreasing. The guidelines above will also work if the interval a and b is replaced by an interval of the forms negative infinitive to b, a to positive infinitive, or negative infinitive to positive infinitive. Alright, and the last but not least, definition. A function is strictly monotonic on an interval if it's either increasing on the entire interval or decreasing on the entire interval. So you look at this one right here. This one is strictly increasing. This one is strictly decreasing. Right? The function is f of s equals s cubed. This one f of s equals negative s cubed. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in